So what are this controls chart, where it is applied? We will be discussing in the module 3 contents of video 2. So here control charts. So here it is meant for to set the statistical control limit for the state of process what I'm going to carry out. So it is a device for attaining statistical control. It is a device which judges whether statistical control has been attained or not. So here in the control charts, what it is going to define is, here you are going to set the upper and lower values that are specified for the quality characteristics as soon as some product show variations outside the tolerance. A review of situation is taken and corrective steps is immediately taken. So the control charts indicate that the process is currently under control. Then data from the process can be used to predict the future performance of the process. So here the variations in manufacturers are unavoidable. So control charts tells when to leave a process alone and thus prevent unnecessary frequent adjustments. Control charts are graphically represented based on statistical sampling theory. So whether to accept the lot or reject the lot, or how to remove the defects components, control charts tells about the undesired variations and helps in detecting the cause and its removal. What is the purpose and advantage? A control chart, it is going to tell whether the process is in control or out of control, so that it will be able to take corrective actions. So it determines process variability and detects unusual variations taking place in the process. It ensures product quality level. It warns in time, and if the process is rectified at that time, scrap or percentage rejections can be reduced. It provides information about selection of process and setting of tolerance limit. So control charts built up the reputation of the organization through customer satisfaction. So like this, the control charts helps. So here, this is the control chart where it represents mean, range and proportion of measurement of quality characteristics in samples taken from the process at different times. The mean of the statistics using all the samples is calculated. For example, mean of the means of the ranges, mean of the proportion. A central line is drawn at the value of mean statistics. Standard error of the statistics is also calculated using all samples. So upper and lower control limits are established. So that must be within the threshold value. So the chart, it indicates the center line, it is 10.058 as the limit. Upper control limit is 10.860, lower limit is 9.265. So like this the limit is set. All the components are checked. What all it falls in the limit, it is accepted. What all it is above the limit, all those things are not accepted. So here in the graph, it tells about the quality characteristics on y-axis and sample on x-axis. So based on the sample, you can see where too much variations are there, those components are removed. So what all within the acceptable limit, so that it is considered. If there is too much variation, whether you need rework for this, it is going to take into consideration. Leaving that one point, all other points which is going to fall within the limit, all those components are accepted. What are the types of control charts available is variables or measurement charts. Attributes are present. The variables, it is X bar chart and R chart it is used. And if it is a attribute chart, P chart and NP chart means non-conformance chart it is used. So like these two types of control charts are available. So based on the need inside the industry, I'm going to apply. So control charts for variables, control charts for attributes. So control charts for variables involves measurement of job dimensions. An item is accepted or rejected if its dimensions are within or beyond the fixed tolerance limits. So variable charts are containing detailed and more information compared to the attribute charts. In the attribute charts, it has upon it is based upon go or no go data, require comparatively bigger sample size. Variable charts are relatively expensive because of greater cost of collecting measuring data. Attribute charts are only way to control quality in those cases where measurement of quality characteristics is either not possible or it is very complicated. So what are the advantages of attribute control charts and variable control charts? So advantages is this chart tends to be more easily understood by managers unfamiliar quality control procedures. Therefore, it can provide evidence to quality problems. Related to variable control charts, here, so unacceptable parts can be detected by the attribute chart very easily. So the variable control chart leading indicator of trouble that will sound an alarm between the number of rejects increases in the production process. So like this, both the charts have got advantages. What are the commonly used chart are X chart, R chart, P chart for fraction defectives, C chart for control of number of defects per unit. So here X bar chart it is meant for process average and changes in process variability, measure of central tendency. It will be showing erratic or cyclic shifts in the process. It detects steady progress changes like toolware. It is commonly used as variable chart. When R charts are used, it, so when to stop the process alone, when to chase, go for causes leading to variations, you'll be able to see. It controls quality of incoming material. So X bar chart and R charts, when used together, it is going to form a powerful instrument for diagnosing quality problems. So like this, both charts can be used for quality control aspect.